goes for the reduction half. So I multiplied, I'm sorry, not multiplied, I added 2 electrons on this side so that way I had 2 plus 1 and a minus 1. So collectively, this was a plus 1 overall here. And then between these two, it was a minus 1 still. So I had to add 2 negatives to get me overall -1 from adding these two together to match this -1 on this side. Let me erase this. So yeah, balancing the charge of the electron is probably one of the most difficult parts, because usually when you're balancing atoms, it's easier to see because you're just looking at atoms, right? But when you're balancing charge, you're looking at the charges. You know, so there's sort of a mental shift that has to go on there. Anything else? Yeah.
So will you always specify whether it's acidic or basic that you want it in?
Yeah, you have to specify that.
Okay.
Yeah, if I just said balance it, I guess you could assume acidic conditions if it's not specified. But yeah, if I wanted basic conditions, I'd have to tell you that, and most people will, you know, not expect you to read their minds, so they'll say acidic or basic, right? Yeah.
So for the basic, all I have to do is add hydroxides?
Yeah, that's it. Yeah, so you always have to go through the acidic conditions first, and then go to basic after. Hence Mohio. All right. Mm-hmm.
Can you go over the Mohio thing really quick one more time? The breakdown of it. It's
Right. So it was
balanced miscellaneous.
So miscellaneous atoms first. So we balanced the chromium first on this oxidation half reaction. We balanced the chlorine, which was already balanced in the reduction half. So that's the M part. The O part was the addition of the waters to balance out the oxygens. The H part was adding the H pluses to both reactions to balance out the hydrogens. And then the E part is adding the electrons to both sides, or to one side or the other to get rid of the charge, or to balance the charge. So that's the Mohi, and then the O, Mohio, is just adding the hydroxide to both sides.
Thank you.
Anything else? All right, so that's balancing redox reactions.